right, everybody. Hey, 4-3 additional practice. We are writing what are called trend line equations. Mr. Frankie probably has some special fancy name for them. Who knows?
You dang right I do.
But we're writing the equation line, which is nothing new. It's just new to us because we're writing it in what's called a scatter plot. With that being said, if we look at number one, you guys already know what to do.
31,
We are on page 31 and 32 in your packet, by the way. Scatter plot shows Leanna's elevation above sea level during a hike. Well, if we look, what is trending? Oh, her height is trending up. Okay. Trend line passes through these 2 points. If she starts at 663 feet above sea level and maintains the same rate, how far above sea level will she be after 1 hour? Well, first point here is y-intercept. Well, how far does she start? Where does she start? 663 feet. Kind of hard to see that from the graph. Good thing they gave it to us. We got to find the slope. Well, they did give us 2 points, so we got to use those 2 points. I'm going to do it over here. I'm going to take the big y value minus the small y value because that's what we do. Okay? Sorry, 1,070 divided by 75 minus 30. Okay, well, let's do some math. 1680 minus 1070. That comes out to be 610. 75 minus 30.
45.
I can do that in my brain. That's 45. We take 610 divided by 45. Your slope
Not a good number.
comes out to be, now do you want to write it as a fraction? We better. Okay? 13 and 5/9. So that means my friend Leanna, okay, every minute she's going up 13 and 5/9 feet. That's right. So your equation, slope, constant rate of change right here, 13 and 5/9 here. Okay, y-intercept here, 663. After 1 hour, her altitude will be what? Well, I'm going to put a 1 in there for the 1 hour. No. Why will I not put a 1 there? Because our x-axis represents the number of minutes. And 1 hour is
60 minutes.
60 minutes. So I'm going to substitute a 60 in here for x, even though it says for 1 hour, because 1 hour is equivalent to 60 minutes. So 13 and 5/9 times 60. Oh, I should put this here. 13 and 5/9.
Somewhere around 1,500.
Times 60 plus the 663 feet that she already started, plus the 663. Holy smokes, this comes out to be 1,476 and 1/3 feet. That's where she is.
I guess 1,500.
That's where she is.
Okay.
Not quite 1,500. All right.
That was fun.
Yeah, find slope, find y-intercept. Nothing new. They have the trend line drawn for us. All right, let's look at this one. Scatter plot shows the annual profit. That's how much money a company's making for one airline. The equation of the trend line is this, where X represents the number of years since 2000 and Y represents the revenue. That's how much money they're bringing in. Not profit. That's how much money they're kind of bringing in. What is the approximate difference in revenue between 2003 and 2007?
A lot.
Let's use this equation that they gave us. Okay, let's figure out what our profit was, or revenue, we should say, whatever you want to call it. Okay, why?
It's right.
For 2003, well, 2003 is how many years since 2000? It's 3, so we're going to substitute 3 into that equation for X right here. So, well, this is 1.2 plus 4.1. This comes out to be $5.3. $5.3 they made. No, look at your axis. 5.3 million.
Million people.
5.3 million. Now, let's figure out how much they made in 2007, because we got to find the difference. That means we got to know one and the other and then subtract them. So, 2007, y equals 0.4 times x plus 4.1. What's going in there for x? 7, because we're 7 years since 2000? Well, this is 2.8. 2.8 plus 4.1 comes out to be $6.9. Nope, million dollars once again. Now, what's the difference of those two? Well, if I want to find the difference, take and subtract them. 6.9 minus, Mr. Fricky's liking what I did with the color scheme here. Okay?
Picking up what you're putting down.
The other, 1.6 million is the difference. Okay? That's how much difference there was in profit. Okay? Revenue. All right, here we go. Let's move on down. Number 3.
This is fun.
An Arctic cold front is
Brr.
moving. That's cold. Moving through the area. It is 37 degrees when the temperature begins to drop. Sounds like a y-intercept. Sounds like an initial value.
Sounds like fun.
Scatterplot suggests a linear relationship between the temperature and the number of hours since the cold front arrived. What does the rate of change or slope represent? Well, it doesn't ask what the slope is right now. It just says, what does it represent? Well, this would be your change in what? Degrees or temperature per hour. Right? So what does it show? The change in temperature per hour. Right? Does it say to find it right now? Nope. So we'll just leave it at that. What is the y-intercept for the trend line, and what does it represent? Well, the y-intercept is right there. Better yet, it was given to us. It's 37 degrees. What does it represent? The beginning, I'm just going to say beginning temperature. That's what it is. Starting at 37 degrees before it begins to drop. Now, what equation relates those to? Oh, doggone it. Now I got to
Now we got to do it.
Now we got to find the slope. Well, let's use the y-intercept, 0,37. And let's find another point on that line. Now, I look on this line. Mr. Friggy, you like this point?
Yeah,
or
I'm good with
you like
that.
this point?
I like 425.
Okay, let's use this point. That is the point 4,25, everybody. 4,25. Find the slope. Big y value minus small y value. So I'm going with 37 minus 25. 0 minus 4. This is 12. This is negative 4. 12 divided by negative 4 is negative 3. That makes sense because this is a decreasing function. Slope has to be negative. So the equation, slope, y equals negative 3x. Where's it starting? Plus 37. What does this mean? It's dropping 3 degrees per hour. That's the temperature it's changing per hour. Okay? You ready to move to the back?
I am if they are.
Let's go. All right, another trend line, everybody. Scatterplot shows the number of passengers at a major airport over a 15-year period from the year 2000. About how many passengers traveled through the airport in the year 2011. Oh, I like these. You know why? Because we really don't have to do anything but interpret this graph. Let's go to 2011. 2011.
I don't see 2000. I don't understand.
Oh, no. Well, it's the year since 2000.
Oh.
2011 would be 11 years since. That would be right here. So let's go right up on the 11. And right on over to there. Round to the nearest tenth of a million. I'm just going to say 65 million. Can we do that?
I think we can do whatever we want.
Okay. 65 million passengers.
Also, the amount of money the Vibe car is worth.
Especially with new headlights and a new cabin air filter.
New air filter, yeah.
That's right.
That really ups the value.
Ooh, higher order thinking. Okay. Tricked you. Let's go. Unless Mr. Friggy says
No,
let's do the
I
higher
was
order.
been waiting for you to get to these last two. These are my favorite two questions right here.
Yeah. All right. Well, when we read this, we got Maria's distance from her house during the first hour of her drive from the beach. The trend line passes through those 2 points. I'm glad they gave us those 2 points. Okay? Especially this one. This is my y-intercept, 0,94. Which of these is the trend line for the data set shown? Use X to represent the time in minutes and Y to represent the distance in miles. Okay. So which one of these equations? Now, let's just use some common sense. Is this thing decreasing or an increasing function? Or linear equation?
Constant.
Whatever you want to call it.
Constant.
No, it's not constant. It doesn't go straight across. That bad boy is going down. So that means my slope has to be negative. So let's identify some slopes. Negative, 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 negative. Daggone it, doesn't help. Well, let's go to the y-intercept. It's set up here. The y-intercept is 94. That's 94 miles from home. That would be a positive 94. So let's get rid of the ones that are not positive 94. Okay, so I'm getting rid of letter A because that's a negative 94, and I'm getting rid of letter B because that's a negative 94. Now, common sense, again, folks, is sometimes what you have to use in life. Which one of those is not written in the form y equals mx plus b?
D.
Y equals.
The one that says x equals?
Get rid of that one, okay? We eliminated 3 answers without really doing a whole lot of nothing, okay? There's the correct equation. You like that?
Yeah.
Okay, predict the distance Maria is from her house when she has been driving for 45 minutes. Well, 45 minutes is on the x-axis.
I'm going to guess
We're going
57.
to take this equation.
I'm going 57.
Y equals negative 4/5 times x. Well, what is x? X is our minutes. In this case, 45.
45, peeps.
Plus 94. This is just a, hey, evaluate that expression. Let's take negative 4/5. Negative 4/5 times
Negative
45.
36 plus 94.
Add the 94.
Oh, I was off by 1.
She's 58. Now, what does that 58 represent? Our y value is
58 Ys.
Okay? That means our y value right there, miles. She is
Bam.
58 miles from home.
Miles.
Folks, that's trend lines, writing trend lines, using trend lines to find information. Check out your Math Excel 4-3. See you.